Hey everybody, how's it going? AMP here. Today I wanted to talk to you about web components and microservices and how I think that they are a match made in heaven. And the reason why I think that is because web components and microservices both contain an immense amount of functionality and both abstract that into an API that makes it very integratable, very chainable, very predictable. And you can manage those at a scale that we've never been able to do before. And I think that web components could be the perfect interface for our users to be able to control really sophisticated, really complex microservices in an easy and sustainable way. So before we get into the nuts and bolts of what that means, we have to step back and take a look at what we did before. So this was the monolith before the world of microservices was here. It absolutely served its purpose. I came from a Drupal background. I get it. I get what it means to be able to have complex user roles and permissions and be able to give people the ability to add and customize rich media and create their own content types. However, this was built using the technology of the time, and it was solving problems with that technology in mind. And I would argue that we've progressed from that stage. So where I think that we are going is the microservices approach to solving these complex problems. So to break down what the microservices approach is it's pulling out pieces of functionality from our monolith that were once all completely coupled together, pulling those out into their discrete purposes, and creating a service that fit those needs, that solved that distinct problem. And what that gives you is the ability to roll out new services, revamp existing services. You don't have to do everything at one time. A lot of times what happens with the monolith is that you're afraid to roll out new functionality because you're not sure how that will affect the whole system. So that's where microservices really shine. Now on top of that, we also have what's called functions as a service. So this is taking the microservices approach to the extreme. This is breaking out individual functions that you would find in a microservice or an entire bundled monolithic application. And you're breaking those down into their own discrete little functions that can be chained together. So it can be tough to recognize what the difference is between a microservice and a function as a service could be. So one of the characteristics for a microservice that it could have is state. It could know about how it's being used, what users have altered certain settings, certain aspects about that application that need to be shared with everybody using that application. So it could have its own UI. It could have multiple routes if you're thinking about what the backend API looks like. It could have multiple create, read, and update resources that you would expect in a microservice. It could have its own authentication, could have its own users' roles and permissions. That is very different from a function as a service, which most often has no state, it has no UI, it has a single point that you can call. So a single API endpoint that is expecting input-output. You send me something, I'm going to send you something back, and that's all I'm going to do. Now, what you can do is you can chain multiple functions together to get something approximating what a microservice could do. Now, recognizing and understanding the differences can be tough whenever it's just looking at the definitions. So let's take a look at some real-world examples to see how these play in the real world. So if we take a look at a website like DataCamp, I think that DataCamp does microservices and potentially functions as a service very well. So for instance, if you're starting a project and you're on DataCamp, you refresh the page and you immediately see that it's loading a Jupyter notebook. This Jupyter notebook is a microservice. Jupyter notebook is a project that's maintained by and used by a lot of people. It has its own UI, it has its own infrastructure behind it potentially. And in this case, DataCamp is using it by every time the user refreshes the page, it's loading a new instance of that microservice and presenting it to the user. So the user sees their Jupyter notebook. This is not interfering with any other users that are also using this system. So there's one more thing that I want to point out with this interface. Something that really tells you if it's a microservice approach or not is if we inspect the underlying source of this page, we can see that this is just an iframe that is being loaded in by something that's called multiplexer.datacamp.com. In contrast, if we look at the next example of what I believe is more of a function as a service approach, we see something very similar. We see this nice UI to the side where we can interface with it. We can click run code and it obviously processes something, gives us a result, in this case a line chart. The difference, however, is if we look at the underlying source, we can see that we're not, in fact, in an iframe. So what's happening is that this element on the page knows exactly how to take this input from the user, send it to some running function, or and come back with a result. In this case, some output from a server and a graph. So that's very important to recognize whenever we're talking about the differences between microservices and functions as a service. In this example, we were loading an entire Jupyter Hub notebook that is its own self-contained project. In this example, the app itself is leveraging these functions as a service behind the scenes that you can't see, but they know how to go back and get this dynamic functionality. And that means that you can control the entire user experience end to end. Knowing all that, let's take a look at a project that we've been working on called Containers on Demand. Now, what this is it's a service that's going to allow you to spin up new services, new microservices to be specific. So if you can imagine, we take that example from DataCamp where we were loading up a Jupyter notebook. Well, what if we could load up any application? So Jupyter Notebook, RStudio, Shiny Lab, some editing software, whatever. And then on top of that, what if we could use a web component to control this service? If you run the demo that's in Containers on Demand, you should see this. And what this is it's a demonstration of just a static web page with a component, web component, that knows how to spin up new microservices using Containers on Demand. What that will look like to the end user is they will get simply a Start Lab button. So this Start Lab button is actually the web component itself. And whenever I click on it, it's going to know how to communicate with the Containers on Demand backend to spin up this custom Jupyter Notebook assignment right in my browser without me having to leave anything. So on that same page, I can scroll down and start a new assignment, in this case, RStudio Lab. This is an entirely separate application, serves a new purpose, has different resources, different infrastructure to support this. But to the student experience, we don't have to leave anywhere. Everything is set up for us. There's no instructions on how to set this up. The web component is taking care of that for us. Similarly with a Shiny application that takes a specific infrastructure to run. To the end user, they shouldn't need to know that, and they don't have to, thanks to the web component. If we wanted to spin up an entire new server for them to play with, we could do that. So Containers on Demand is solving the microservice approach. So what about functions as a service? Where do web components tie into that? So I'm going to go to an example application here, which is running a web component called rcoder. Now rcoder, what it does is it presents the user an IDE, in this case VS Code, so that we can code right in our browser. And it gives us this process button. So what the instructions are telling us is that they want us to compute this R code by printing out the result of A plus B. I hit process and I get back 45. Now what is happening there? So the web component is responsible for presenting the user experience of writing R code and seeing if you got it right or wrong. And it knows how to do an accessible version of a code editor. It knows how to make the button accessible. We can match this experience to the rest of our application so it looks streamlined. It looks like it came from the same application because we're controlling that whole experience. But on the back end, it's using a function to process our code and come back with the response. Now, what those functions look like is you would typically have a functions as a service manager to manage all these functions that you would have. So for instance, you have Figlet, which turns text into ASCII art. So if I give Figlet, hey MP, it should respond with ASCII art, hey MP. If I do face detection and I point it at an image of this person sitting on a ledge, it will process that for me. If I use this text-to-speech plugin and I say, hi there, it will process that text, come back with the result.
Hi, they're OPENFAAS.
And come back with the MP3. So you have all these functions living in your backend. The web component is a great way to give end users the ability to tap into those services. So in summation, I think we should start moving to more microservices-based approach. One of the challenges is how do you orchestrate those efficiently? How do you manage those? How do you give those the ability to the end users to control those? I think that's where web components really shine. I think the combination of microservices and functions as a service could be an extremely powerful combo for the web, especially whenever web components are at the helm. I hope you liked this video. Please, if you have any questions or comments, please don't hesitate to reach out. I'm hey__MP at Twitter. And thank you.